Well, first of all, good morning, everybody. I wanted to thank the organizers of Robotech for actually bringing me here. I come from New Zealand. I'm originally from the Philippines, also in the US. But yeah, it's so great to be here in Estonia. It's my second time. But so let me talk more again about space and the democratization, more on the entrepreneurial angle. So next year is going to be the anniversary of the Apollo moon landing. It's the 50th anniversary. I was born during the Apollo era, and actually here's Buzz doing his first spacewalk during the Gemini program, which makes me really old compared to the Generation R that we're kind of like highlighting in this conference. This is me back in the Philippines, chasing basically eclipses. And I think fast forward 30 years, my 20-year-old self probably would not have imagined what I would be doing now, and what the current space situation is now back then. But the thing is, there's a lot of things that have happened between when we landed on the moon, but there's also a lot of things that have not happened. So let's just take a look at this. In 1996, the Ansari X Prize basically opened up the suborbital space industry with a $10 million prize. The first private company to go up in space and do it again in 2 weeks' time. I was very fortunate to have seen Spaceship One basically fly all 3 of those flights in Mojave. But 15 years after, the 24 space startups that have actually come forward for those teams are almost now gone. And 15 years after, we're still waiting for the first commercial flights. So that's kind of a little bit of a disappointment. The other thing as well is around about the same time frame, I was very lucky to also have worked for the only space tourism company that has sent private citizens to space. So there's about 7 that have gone up. But they all basically paid $20 to $50 million to get up there in the ISS. And unfortunately today, it's still a monopoly. The Soyuz spacecraft, which is essentially the same spacecraft that sent Gagarin up on the very first flight in 1961, is still the same spacecraft that we're using today as the only man-rated flight that's existing today. So I'm in that respect, I'm sort of really disappointed that this is what has happened, and we haven't really moved further so much. However, this year, this happened. Remember this? With SpaceX, essentially 2 rockets, reusable first-stage rockets, going back down to Cape Canaveral, and just, I don't know about you, but this blew my mind away. This is one of the holy grails of rocketry, which is reusability. The other thing that happened this year as well is that the startup company called Planet managed to finish basically launching all of their nanosatellites, and today we can image the Earth 24/7. This company has just been around for essentially the last 7 years, and now they have the biggest constellation of satellites today. And then lastly, as an example, is 3 weeks ago, if you can turn down the sound. 3 weeks ago, in a very isolated country, basically in the middle of the Pacific, New Zealand launched through Rocket Lab the very first small satellite launch market launcher, the Electron, and with a fraction of the cost of launches that we've had today. So that you can launch on Rocket Lab for $5 million compared to SpaceX, which of course is a much bigger rocket, but that's for $60 million. So I feel this year alone, somebody just pressed the ludicrous button on the Tesla Roadster, and all of a sudden, something is happening, which is really great. And so I actually think that for the space industry, we finally reached that inflection point on the exponential curve. And something is about to happen that is like not something that we've only expected before. And this is because of exponential technologies, disruptive technologies that you've been hearing throughout the conference, yesterday and today. These are technologies from AI to robotics, nanotech, and nanotech that essentially are powered by computing, powered by Moore's law, and that are accelerating at an exponential rate. So case in point, that smartphone in your pocket, just one, is really 102 million times much more better and faster than if you put all of the computers that were used during the Apollo program together to send men on the moon. I mean, I think that's like really just, it's mind-boggling that the cell phones that we have today that we normally take for granted are really supercomputers. So essentially what has happened is that these technologies has put the space industry, we're moving towards an era where we used to be big, expensive, and essentially exclusive to big governments and big aerospace companies, to now small, much better, and off the shelf. And this is started the CubeSat sort of like revolution that you're seeing today. I always think of CubeSats now as an analogy as the new smartphone, and the sensors that are in the CubeSats are actually the apps on your cell phone. And that analogy goes further because essentially this CubeSat revolution was really started by 3 guys in a garage in Cupertino in California. This is Planet, essentially. I don't know if you can actually see the satellite on there. It's on the table. And these guys, how did they start? They started experimenting by launching phones up in space. And just like trying to see whether the components of a phone can withstand the vacuum of space and all of the rigors that entails, which actually it did. And so today, components of CubeSats, like the Dove satellite that Planet normally builds, is really made out of components from your iPhone or your phones, which is pretty amazing. And because it's now cheaper and easier to build, like with Planet, they just keep building and popping all of these small satellites so easily. So much so that in 2017, last year, if you look at the graph there, that spike in the number of satellites that have been launched for the last 2 decades, that spike there, the blue line there, is just Planet, essentially. Last year, they managed to launch about 80 of their nanosats just in one launch, and not through US, but also through an Indian satellite in Israel, and that's also a world record. So the other thing that disruptive technologies has done is that it has basically demonetized, space technology. And so here's another example. Today, when we think about our weather data, we get that weather data from big, expensive satellites. And to get that data, we also need big ground stations that are, like $500,000 to actually build. And so it's very expensive. But today, you can go online and buy essentially a software-defined radio for 29 New Zealand dollars. I guess it's $25 for US. And if you have an unencrypted satellite that's going, overboard, you can actually get the same imagery today for free, and then also analyze that imagery using open source QGIS software. So really, all you need today is internet to be able to play kind of like in this industry. Another example is that because, again, the components are just off the shelf, you can go online and buy essentially the components of a satellite, integrate them in a few minutes, and this company from Bulgaria, Endurosat, can actually deliver that platform of a satellite in 5 days. So Endurosat has also sent up their satellite just a couple of months ago. So this is like not a knockoff of components that you'd probably think of when something is basically being peddled online. So another example is that in that launch from Rocket Lab 3 weeks ago, there's also like 2 Australian satellites from the company Fleet. And from build to integration to launch to all of the licensing and basically paperwork requirements that they needed to finalize with the New Zealand Space Agency, that happened within a matter of weeks, as opposed to the 2-year or 18-month cycle of actually getting a satellite system prepped to actually launch. So with all of this democratization, some of the big players, again, like SpaceX and Airbus, are, well, because now it is so cheap to actually launch and build satellites, they're now working on the kind of like the moonshot of communications, which is internet everywhere. And you've heard about this through other speakers this week. And what was the consequence of this? Well, that means that a number of big constellations will need to be launched up there to actually make this happen. And so thousands of satellites are now being potentially prepped to launch. Right now, there's about like 20,000 that they're thinking of being launched. And the thing is, right now, there's only Rocket Lab and, of course, like SpaceX and the traditional launch companies that are actually like launching up there. So to saturate the market, you'll need about 30 of these new small satellite launchers to be able to actually bring all of these satellites up. And today, there are companies like Virgin Orbit, Vulcan, other companies that are vying for this. And actually, I heard somewhere that there's about 100 of them, startups and medium-sized companies who are trying to do this. Of course, not all of them will succeed, but that's something that for sure will hopefully happen. So that's what's happening in the short term of the space industry and why disruptive technologies are actually very important to this. But then let's look at what's out there and what's for the future. So we know that NASA and ESA has been working on Moon and Mars missions to date, but also now, again, with the democratization of space and leveraging exponential technologies, companies like SpaceX and Amazon's Blue Origin, to even traditional aerospace companies like ULA, a consortium of Boeing and Lockheed, are now looking at big missions to Moon, Mars, and like space depots in between Moon and Earth. And the thing is, this is no longer PowerPoint slides as well. I mean, I've been to some of these rocket factories, and the hardware is real, and they're gigantic. So it's happening today. And the thing is also, in the past, during the Apollo era, we had a race. And the motivations for all of these were different. It's like planting a flag in a nation's name, or basically space exploration for space exploration's sake. But today, there are other motivations, one for which is backing up the biosphere. And I'm sure you've heard Elon Musk talk about this, where you don't put all of your eggs in one basket. You want to make sure that Earth has a backup just in case something happens to us. But I think the other thing that is more interesting, really, is the long-term sustainability of Earth and humanity is going to be based on how we will be able to get resources like off-planet to really sustain humanity as we go forward. And so this is why most people think that the moon is one resource or one place that we could potentially find those resources, especially now that we've found water on the poles. But other people also think that the asteroids are probably a much better place to go. So back in the 80s, we know of about like 12 near-Earth objects or asteroids. Today, there's about 20,000 that we know of, and that's only what we know. And every month, there's always something new. And so for other companies today, this is no longer the doom and gloom, the dinosaurs being annihilated and potentially us being annihilated. Now it has become potential for opportunities and resources. I know I'm probably gonna run out of time. So this is one example of probably capturing an asteroid. And I won't go into details. You can look this up, but it's one that is very interesting. It's very complex to actually be able to capture an asteroid, and this is just one example. But the point is essentially is that today space industry is no longer just rockets and rocket ships. So all along that supply chain, with these big missions for settling other planets and the solar system, there are niche markets in between that have terrestrial applications at the same time that people now can actually look at and potentially be part of for these bigger missions that are coming up. So, for example, looking at habitations when we do actually settle out there. So this is one niche market that you could potentially look at. Others are essentially how are we going to grow food? I mean, today we're looking at essentially vertical farming and hydroponics for Earth because of already the growing extreme environment that is happening on Earth, and that's more so out there in space. Other things is that today space is actually expensive because we always launch everything that we need up. And so what happens if we can actually manufacture things in space? So that's one thing. We would also need essentially energy that we would need for operations out there, and then also maybe energy that we could beam down here. There's also, of course, robotics, where the precursor missions for settlement will be autonomous and robotic before humans start settling. So that's another thing to be looking at. So this is not lost in the entrepreneurial community. It's interesting that within the past year, there's just more space startup and entrepreneurs and companies that have actually been birthed than any time during the past kind of 2 decades that I've been sort of monitoring the space industry. And again, there's also a lot more investors and accelerators that have basically come online to really focus on resources for space-related industries. And lastly, there are now a new breed of companies that are leveraging cryptocurrencies and blockchain to really look at what is the space marketplace of the future and how are we going to be trading when we go off-planet. Is it still going to be money, or is it going to be one universal credit that is all digitally based? So to conclude, actually, the future is here. The future of space is here, whether we're really already, whether we're ready for it. And the thing is, the ones that are going to be successful are people and companies that can basically leverage these exponential technologies and use them to essentially to look at the vision for the future in 10 years and work backwards and work now using and leveraging those technologies. So I leave you with a quote and maybe a challenge. What do you think is Estonia's role going to be for the space industry that is coming up pretty quickly? So I'll end here, and I encourage you to also come to my other talk at 11:15 in the workshop, because I'll be talking more about what we're doing in New Zealand today to actually create an industry and an ecosystem. Kia ora, thank you.